In this video, we will talk about what Bayes probability problems are and how we can solve them with tree diagrams. So I want to begin with a definition. So a Bayes probability, problem is one in which it is easy to find a conditional probability like P of A given that B occurs, but our goal is to find the reverse direction. Our goal is to find the probability of B given that A occurs. So we actually saw some problems like this. We saw, there we go, saw some in section 3.3. Someone put a smiley face there. So these aren't going to be completely new for us. And as we saw in section 3.3, we can solve these using tree diagrams. Using tree diagrams. There's also a formula for Bayes probability questions, but I'm not going to talk about the formula in this section just because I like the fact that we can really visualize where things are coming from when we do it with tree diagrams. Alrighty, so let's do an example. Here is the example. It says, in the last 5 years, FC Barcelona has won 65%, lost 15%, and tied 20% of its games. Leo Messi scores in 70% of wins, 25% of losses, and 40% of ties. In a randomly selected game in which Leo scored, find the probability that Barcelona doesn't win, and round your answer to 3 decimal places. Okay, so let me begin by writing down what it is that we want to find. We want to find a probability that Barcelona doesn't win. So let me write doesn't win. But there's something that we're given, because it says right before that it's a randomly selected game in which Leo scored. So we're given that he needs to score. So, all right, given that he scores. All right, so let's set this up using a tree diagram. Okay, I'm going to zoom it out a little bit so I can see the problem while we form this tree diagram. Okay, so let me write a section for where we're going to begin. And it's natural to set this up with a tree diagram because there's a few stages to what's going on here. There's a matter of the result of the game, whether they win or lose or tie, and there's what happens with Leo. Does he score or does he not score? Okay, and then I can form the outcome. And then finally write the probability of that outcome occurring. Alright, so for the result of the game, we have 3 possibilities. Either they could win, they could lose, which I'll call L, and they could tie, which I'll call T. In fact, in the problem, let me just go back and label those outcomes. So for a win, I'm going to call that a W. A loss, I'll call L, and a tie, I'll call T. There's also going to be a matter of does he score or not, so let me call scoring an S. Okay, so now from each of these branches, we write the outcome for Leo. So either he's going to score, which is S, or he won't score, which I can call S complement. So same thing from L, I could draw an arrow to S, him scoring, or to S complement if he doesn't score. And also from tie, either he scores or he does not score. Then we can form the outcomes, so WS, WS complement, LS, LS complement, TS, TS complement. And now let's fill in some of these probabilities. So in the first sentence, it says that Barcelona wins 65% of the games. So I'll write a 0.65 on this branch. They lose 15%, so I write 0.15 on this branch to L, and they tie 20% of their games. So I write 0.2 on the branch going to T to tie. Alrighty, so next it says Leo scores in 70% of their wins. So when they do win, when I'm at W, he's going to score 70% of the time. So this is 0.7. But when they lose, he scores 25% of the time. So from L going to S, I write 0.25. So he scores much less in their losses. And then finally in their ties, he's scoring 40% of the time. So I put a 0.4 there. And then I can get these missing probabilities. So from W going to S complement, this should be a 0.3. Because it needs to add to 0.7 to give me 1. So similarly, down here, L to S complement, this will be 0.75. And then T to S complement, this will be 0.6. So that it adds to that 0.4 to give me 1. Alrighty, so now we're ready to multiply these to get the probabilities. So this first one is going to be 0.65 times 0.7. And then I'll have 0.65 times 0.3. Then it's 0.15 times 0.25. 0.15 times 0.75, 2 more, 0.2 times 0.4, and 0.2 times 0.6. So let's multiply these out. Okay, so for the first one, if we work out what this is, we get alrighty, so multiplying those, we get 0.455. The next one is 0.195. Then it's 0.0375, 0.1125, 0.08, and then finally 0.12. Alrighty, so we are ready at this point to try to find the probability that he doesn't win, given that he scores. So using my formula for conditional probability, the numerator is going to be a probability of the intersection of two things, so that he doesn't win, intersected with the event that he scores. Remember, intersection means the word and. So the numerator is going to ask for the probability that he doesn't win and he scores. And the denominator is going to be the probability that he scores. It's whatever we are given that goes on the bottom. And we are given that he scores. Okay, so let's focus on the numerator, the probability that he doesn't win and that he scores. So that happens in two outcomes, where he doesn't win and he scores. That happens in LS, he loses and he scores, which is this, as well as TS, because he ties and he scores, and that's this value here. So if I put those together, we get 0.0375 added to 0.08, and that's what we have on the numerator. So let me highlight that in blue. And on the denominator, we need the probability that he scores. So he scores in this outcome, and this outcome. So there's 3 outcomes in which he scores. We are going to need to sum up those values on the denominator. So we'll get 0.455 plus 0.0375 plus 0.08 on the denominator. And if we work this out, let me make this fraction a little bit smaller. This ends up giving us 0.1175 on the numerator. It gives us 0.5725 on the denominator. And if we round that to 3 decimal places like the question asks, this gives us 0.205. And that is our probability. Let me just end by highlighting this one in green as well. In terms of our goals for this section, we have finished our first goal, which is defining what a Bayes probability problem is. It's something we've actually seen before. We're just giving a specific name to it. Over the next few videos, we're going to continue to do examples, but the theme in this section is going to be, the examples are going to be more challenging than the ones that we saw in section 3.3.